This little lesson is on parallel and perpendicular lines. So to start, we're just going to go through the investigation that appears in section D of the learning guide. So right now we are on page D1 in the learning guide. So you want to have your learning guide open so that you can sort of follow along with what we're doing and write down what we write down. So this investigation is about parallel lines. So they ask us to look at the diagram on the right. In this diagram, there are two lines. Let's label these line 1 and line 2. How would you describe the relationship between these two lines? These are parallel lines. And we know that they are parallel lines because they're running basically in the same direction. They're the same distance apart. They don't get any closer. They don't get any further apart. They are never going to intersect each other. They ask us now to determine the slope of each line. And we've done this a few times now, so we know that if we're looking at line 1 here, we can pick a couple of points that are easy to get the coordinates of. And in this case, we can even just draw our little slope triangle here. We can look at this and see that our rise is -3, our run is 2. So the slope of line 1 is going to be -3/2. We can do the same kind of thing for line 2. We can pick 2 points which are easy to get the coordinates of. I'm going to pick those two there. We can draw our little slope triangle in here, and we can see that our rise is equal to -3 and our run is equal to 2. So the slope of line 2, rise over run, is -3/2. What do you notice about the slopes of line 1 and line 2? Well, -3/2 and -3/2 are the same, so they are equal. This leads us to the conclusion that you can see in the middle of the page. If the slopes of two lines are equal, the lines are parallel. If two non-vertical lines are parallel, then their slopes are equal. And down at the bottom, they give us this little example here. Are the lines A and B parallel? Let's see, y is equal to 5/3 x plus 7. Line B is y equals 5/3 x minus 1. And in our solution here, we just have to pull out the slopes of these two lines. The slope of line A is 5/3. The slope of line B is 5/3. Just by looking at the fact that those two numbers are equal to each other, the slopes of the two lines are the same, so the lines have to be parallel. All right, let's move on to the next page here. This is page D2, and this is the second part of the investigation. Here we are looking at perpendicular lines. So in the diagram that we have here, they have given us two lines here, and these two lines are perpendicular to each other. It may not look like it in the diagram, but they are perpendicular. So I'm going to skip to the middle here, and where it asks me, how would you describe the relationship between the lines in the diagram? I'm going to say that they are perpendicular. Now they want us to do something similar to what we did with the other two lines. They want us to determine the slope of line 1 and then the slope of line 2. So let's label this. We'll say that this is line 1 up here, and this line over here is line 2. For this one, we can do the same kind of thing we did before. We could be using our slope formula here, but it's probably just as easy to figure out our rise and our run. So for line 1 here, we have a rise of 2, and we have a run of 1, 2, 3, 4. So our slope is going to be rise over run, 2/4, or 1/2. This makes sense. Our line is going up as we go from left to right, so our slope is going to be positive. Line 2 is going down as we go from left to right, so we know that our slope is going to be negative. We can do, maybe we'll switch colors here just to make it a little easier to see what's going on. And we can draw our little triangle here between our 2 points. We've got a run of 2. We have got a rise of 1, 2, 3, -4. So the slope of line 2 is going to be -4/2. Or if we put this in lowest terms, it'll be -2/1, or just -2. So how would you describe the relationship between the slopes of the two lines? And let's look specifically at these two forms right here, 1/2 and -2/1. How are these two fractions related to each other? Well, they have the same numbers in them, okay, 2 and 1. One is positive and one is negative, but the fractions are flipped over. So we call these negative reciprocals. What does this mean? We can say that the fractions are flipped relative to each other, and the negative part just refers to the fact that they have opposite signs. So we'll say plus opposite signs. Then they ask us to do something, multiply the slope of line 1 times the slope of line 2. So again, I'm going to work with those two forms that I have there in green squares. Line 1 had a slope of 1/2. Line 2 had a slope of -2/1. If I multiply them, multiplying two fractions, I just multiply the numerators. I get -2/2. -2 divided by 2 is just -1. So these are the two relationships between the slopes of lines that are perpendicular to each other. The slopes are negative reciprocals, i.e. the fractions are flipped and they have opposite signs, or the two slopes multiply to -1. And this is the conclusion that they give us in the middle of the page. In the coordinate plane, two lines are perpendicular if the product of their slopes is -1. The slopes are negative reciprocals of each other. So let's look at our example here. Are the lines A and B perpendicular? The slope of line A is 5/3, the number that appears just before the x. The slope of line B is -3/5. Again, the fraction that appears just before the x. We can look at these two. They do it by multiplying them together. 5/3 times -3/5. They get -15/15 or -1. But we can also see that these are negative reciprocals. If we take 5/3 and this is a positive slope, positive 5/3, and we invert the fraction or flip the fraction over to get 3/5 and change the sign from positive to negative, we have made these things negative reciprocals.